if you read the news today, you would honestly think the electric car is just completely dead. I mean, you see all these headlines about, vehicles gathering dust on dealer lots, major manufacturers pulling back, and just the whole green transition kind of stalling out.
Yeah, the narrative is definitely super heavy on the doom and gloom right now.
Right. But beneath that narrative, something totally counterintuitive is actually happening. Like right now, on just a typical Tuesday, used EVs are quietly flying off dealer lots in an average of, 42 days, and often for under 25,000 bucks. So, welcome to today's deep dive. We are looking at this massive kind of invisible shift happening right beneath our feet.
It really is a fascinating shift.
It is. And our mission today, for you listening, is to connect the dots between the reality of how we are actually buying cars in 2026, the mechanical leaps occurring in battery science, and how that specific package you ordered online actually makes it to your front door without completely choking your city in smog.
Yeah, and we are pulling from a really robust stack of data to do this today. We're looking at fresh consumer behavior metrics from Cox Automotive and Veloz, and then diving into the actual chemistry of solid-state batteries via a technical brief from Tow7 Motors.
Which is heavy, but so cool.
Oh, it's incredible. And then we're tying all of that into this massive study on urban delivery networks from the Urban Freight Lab at the University of Washington, along with some industry logistics from SparkCharge. The narrative out there, like you said, is very binary. It's either a total success or a complete failure. But the data shows we are actually just in a massive, messy transitional middle.
So, okay, let's unpack this consumer reality first, because, looking at that Q1 2026 data from Cox Automotive, the massive drops in new EV sales have actually slowed down. Nationally, the EV market share has kind of leveled out near 6%.
Right.
And in California, which, usually acts as a crystal ball for the rest of the country's auto market, Veloz reports, their new EV market share is sitting at 15.7%.
Yeah, which tells us the market is maturing. It's no longer being artificially propped up by those sweeping federal policies. Those federal incentives largely expired, and the analysts at Cox basically describe what we're seeing now as a necessary reset.
A reset, right.
Exactly.
Yep.
It's being driven by actual market fundamentals now.
Yeah.
I mean, if you look at the historical data they provide, it took hybrid vehicles a 25-year journey to become a mainstream, ubiquitous technology in America.
Wow, 25 years.
Yeah, it's a long time. The EV market is really just entering that maturation phase where, the early adopters already have their cars, and now the industry has to figure out how to sell to the practical everyday driver.
And the data shows that the everyday driver is looking straight at the used lot. I mean, that was the big aha moment in these reports for me. Because back in 2023, the price gap between a used EV and a comparable used gas car was massive. It was something like over 10 grand.
Too easily.
But Veloz reports that today, that gap has just plummeted down to barely $1,300.
Yeah, it's basically a race. The average used EV is now sitting around $34,800, and a staggering 44% of used EV transactions are clearing under that $25,000 mark.
Which is the magic number.
It really is. At those prices, the calculus for just a regular commuter completely changes.
We are essentially seeing the smartphone adoption cycle play out, but with cars. Like, think about a decade ago, you only bought the absolute newest smartphone because the underlying technology was making these massive, unpredictable leaps every single year.
Right, you didn't want the older.
Exactly. You didn't want a 2-year-old phone because it felt ancient. It couldn't even run the new apps. But eventually, the tech stabilized. Today, a 2-year-old refurbished smartphone is incredibly capable and, frankly, perfect for most people.
That's a really good point.
Yeah, the EV market has basically reached that refurbished smartphone phase. And while the federal money dried up, the states recognized the shift and localized their incentives to kind of push it along.
They absolutely did. You look at Maine. Efficiency Maine is putting up to $8,000 on the table for low-income buyers.
That's huge.
It is. New Jersey's Charge Up program takes $4 grand off right at the point of sale. New York just injected another $30 million into their Drive Clean rebate, and we're seeing similar well-funded structures popping up in Illinois and Maryland.
So if the everyday consumer is shifting to the used market because the current technology is, good enough, you'd think automakers would be panicking. Like, how are they going to sell new cars?
Right. You would assume they're terrified.
But reading through the Tow7 Motors brief, they aren't slowing down at all. They're intentionally letting this generation of cars filter into the used market because they are preparing this massive technological leap that will just make current lithium-ion batteries look totally obsolete. We are talking about the solid-state battery.
Yeah, and according to the technical brief, 2026 is the year solid-state transitions from just a laboratory pipe dream into actual real-world commercial production. I know, right? But to understand why this is such a massive leap, we kind of have to look at the mechanics. What's fascinating here is how the chemistry physically changes. Because in a traditional lithium-ion battery, you have a liquid electrolyte.
Right.
It's essentially this liquid solvent that allows the lithium ions to literally swim back and forth between the anode and the cathode to charge and discharge power.
And we know the inherent flaw with that liquid is that it is highly flammable. Like if the battery gets punctured in a crash or just gets too hot, that liquid solvent can ignite and trigger thermal runaway.
Exactly. But in a solid-state battery, you engineer that flammable liquid completely out of the equation. You replace it with a rigid, solid material, typically things like polymers, oxides, or sulfides.
No liquid at all.
None. And the immediate benefit is thermal stability. A traditional lithium-ion battery can begin to experience thermal events at just 90 degrees Celsius. In a solid-state system, the researchers report that threshold jumps all the way up to 247 degrees Celsius.
See, I've heard people compare this to swapping out a flammable liquid moat for a solid brick wall, but that analogy never really made sense to me. Because if it's a solid wall, how do the ions actually move to create power? A battery has to have flow, right?
Yeah, that's a common misconception. Think of the liquid electrolyte like a kind of chaotic, wide-open river. The ions just sort of swim across however they can. A solid electrolyte is more like a high-speed rail network that's been drilled straight through a mountain.
Oh, I like that.
Yeah, the solid material is engineered at a molecular level with these very specific structured tunnels. The ions travel through those designated tunnels incredibly fast. It is a highly organized, very efficient transfer.
And because you have that organized transfer and a battery that doesn't literally burst into flames, you can fundamentally change the rest of the battery's architecture. Like the TO7 brief mentions swapping out the graphite. How does that work?
Okay, so in current batteries, the anode is usually made of graphite. The graphite basically acts like a heavy, bulky parking garage. Its only job is to provide physical space to hold the lithium ions when the battery is charged. But solid-state stability allows you to just demolish the parking garage entirely. You can use a pure lithium metal anode instead.
So what happens to the ions?
When you charge the battery, the lithium ions just plate directly onto each other, forming their own temporary metallic layer.
Wow. So you save massive amounts of physical space and weight because you aren't lugging around thousands of pounds of graphite sponge everywhere you go.
Exactly, which is how you achieve those massive density numbers. The brief targets an energy density of 400 to 500 watt-hours per kilogram, which is roughly double what current batteries achieve.
Double.
Double. That mechanically translates to ranges exceeding 1,000 kilometers on a single charge.
That is insane.
And because those solid molecular tunnels can handle extreme electrical currents without degrading or overheating, charging the battery up to 80% takes just 10 to 15 minutes.
Plus, liquid freezes, right? Follow tunnels don't. The data from Dongfeng shows their solid-state battery retains 72% of its capacity even at negative 30 degrees Celsius.
Yeah, it basically solves almost every single limitation of current EVs.
Okay, wait. If this chemistry is so flawless and solves every single problem we have with range, charging time, and cold weather, why are we sitting here in 2026 without them in our driveways? What is the catch here?
The catch is the microscopic manufacturing reality. I mean, the TO7 Motors brief doesn't hide the hurdles at all. Take sulfides, for example, which are one of the most promising solid materials.
Okay.
If a sulfide comes into contact with just the ambient moisture in regular air, it reacts and releases toxic hydrogen sulfide gas.
Oh, that's not good.
No, it's terrible. So you have to manufacture these batteries in ultra-dry, perfectly sealed, multi-million-dollar cleanroom facilities.
Which means the upfront production cost is just astronomical compared to our current gigafactories.
Exactly. And there is also a major physical hurdle called interface resistance. A liquid naturally flows into every microscopic bump and groove inside the battery.
Yeah.
It creates perfect contact. A solid doesn't.
Right, because it's rigid.
Imagine rubbing two pieces of rough sandpaper together. They only really touch at the highest microscopic peaks. There are tiny air gaps everywhere else. If the solid electrolyte and the electrodes aren't perfectly flush-like down to the nanometer, ions get stuck at those gaps, and the battery becomes sluggish.
And the brief mentions dendrites, too, which is weird because I thought solid batteries were supposed to completely fix that.
They suppress them, but they don't completely eliminate them. Dendrites are these tiny metallic needle-like whiskers that can grow off the lithium as the battery charges and discharges.
Oh, okay.
Over time, these metallic needles can literally physically pierce through the solid electrolyte and cause a short circuit. So engineering materials that are tough enough to block those microscopic needles while still letting ions flow through the tunnels is basically the final major manufacturing hurdle.
Right, so because of those extreme manufacturing costs and hurdles, these true solid-state batteries are not going straight into mass-market commuter stands just yet. The rollout is happening in phases, and right now they're heavily targeting micro-mobility like premium e-bikes and heavy-duty commercial vehicles.
Yes, and if we connect this to the bigger picture, putting a 1,000-kilometer fast-charging super battery into a commercial delivery van immediately exposes the next major bottleneck.
The infrastructure.
Exactly. Which brings us to the Urban Freight Lab study. They lay out zero-emission delivery as this three-legged stool, and the first leg is electrifying the fleet.
Which makes sense. And the logistics companies are desperate for these vehicles. I mean, Amazon is rolling out tens of thousands of Rivian vans, and PepsiCo is pushing their Tesla semis. But as the Urban Freight Lab points out, securing the vehicle is actually the easy part. The catastrophic problem is the electrical grid. Like if you have a depot with 50 or 100 massive delivery vans, you cannot just plug them into the wall.
No, not even close. A single fast charger can pull as much momentary power as an entire grocery store.
A whole grocery store.
Yeah, if you put 50 of those in a single parking lot, you need a completely new neighborhood substation. The local utility company literally has to dig up the streets, trench new high-capacity transmission lines, and install massive transformers just to bring enough juice to your facility.
It is exactly like buying a fleet of the world's most advanced, battery-hungry laptops for a corporate office building, only to realize the building was constructed in the 1920s and has absolutely no electrical outlets.
That's a perfect way to put it, and the delays are measured in years, not months. The Urban Freight Lab highlights a really staggering piece of context here. Over 90% of U.S. trucking companies operate fewer than 10 trucks.
Wow, 90%.
Yeah. Roughly 60% are just single-owner operators. Only the mega corporations can afford to suit multi-million-dollar depot overhauls and wait 3 years for utility permits. The smaller players are entirely priced out of depot charging.
So the industry had to pivot. According to the Spark Charge Industry Overview, logistics companies are turning to this massive loophole called Charging as a Service, or KSS. Basically, instead of begging the utility company to trench new lines to their depot, they just use mobile battery trailers.
It is totally grid-independent infrastructure. SparkCharge and similar companies are basically building massive portable power banks on wheels.
Just driving the power around.
Exactly. They charge these trailers slowly off-site, where the grid can actually handle it, and then they physically drive the power to the delivery fleets at night.
It allows a logistics operator with, say, 5 vans to get fully powered up and running in under a week, completely bypassing that multi-year utility queue.
It is a totally critical bridge solution. It keeps the electrification momentum going, while the slow, bureaucratic process of grid upgrading eventually catches up. But the researchers at the Urban Freight Lab point out a pretty glaring reality. Even if we perfectly solve the grid problem and magically electrify every single delivery truck on the road tomorrow, we still have a systemic failure in urban delivery.
Because a zero-emission traffic jam is still a traffic jam.
Exactly.
If I am stuck behind a giant delivery van that is double parked, blocking the bike lane and causing gridlock, the fact that it doesn't have a tailpipe doesn't actually solve the congestion in the city.
Right. Electrifying the powertrain is only leg one. To truly fix urban logistics, the study argues we have to fundamentally change the shape of the vehicles and the actual physical spaces they occupy in the city.
Which leads to the final 2 legs of the zero-emission stool, mode shift and real estate. Let's unpack mode shift first. This is the transformation of the final 50 feet of delivery leg, the physical distance from the curb to your actual front door. The data on cargo e-bikes in this study is just fascinating. We are moving away from the traditional step van entirely in these dense areas.
We really are. In a congested urban environment, a heavy-duty cargo e-bike is consistently proving to be faster than a diesel van. Faster. They completely bypass street traffic, they utilize bike infrastructure, and they park directly at the destination without circling the block for 20 minutes looking for a loading zone. According to the Urban Freight Lab's metrics, when you factor in time, wear and tear on roads, and emissions, the total social and environmental cost of an e-bike delivery is just 12% of a traditional van.
Just 12%. That is wild. And we're seeing private operators scale this rapidly. Net Zero Logistics is running hundreds of cargo bikes in New York for grocery delivery. Beeline up in Portland uses massive trikes to deliver wholesale food to restaurants. And the mode shift isn't just bikes either. Amazon and Walmart are scaling drone deliveries, and you have these personal delivery devices, PDDs, like the Serve and Starship sidewalk robots handling localized food and small parcel runs on college campuses and city streets.
But here's the catch with that. You cannot run a fleet of heavy-duty cargo bikes or, sidewalk robots from a massive fulfillment center 30 miles outside the city in the suburbs.
Right, they run out of battery.
Exactly. They simply don't have the battery range or the speed to make that highway commute. This requires the third leg of the stool, real estate. The logistics hubs have to push directly into the densely populated city centers.
And the researchers emphasize that cities are starting to act as urban space managers to make this happen. They control the zoning laws and the actual concrete. So we are seeing this huge push toward what they call microhubs. Private logistics companies are leasing out underused urban spaces like vacant big box retail stores, empty parking garages, or just old auto shops and converting them into neighborhood staging areas.
And the mechanics of it really rely on this concept of cross-docking.
Okay, what is that?
So a single fully loaded electric semi-truck drives into the city at night when traffic is basically non-existent. It drops off a massive bulk load of packages at the neighborhood microhub. Then, throughout the next day, a fleet of 10 cargo bikes pushes those individual packages out to the surrounding, say, 10-block radius.
And the cities are actually using their authority over the curb as a policy lever to force this shift. According to the data, Portland created designated zero-emission commercial loading zones. If a logistics company uses an EV or a cargo bike, they get preferred, free access to the absolute best curb space in the city. If they use a gas-powered truck, they are just blocked out.
The researchers note this is highly effective because it hits the logistics companies exactly where it hurts: efficiency and parking tickets. But the space management also targets the consumer side through parcel consolidation, specifically using delivery lockers.
Oh, yeah, the Locker NYC pilot program is a perfect example of this. So instead of a delivery driver making 50 separate stops at 50 different apartment buildings, navigating 50 different security doors and buzzers, the city partnered with private vendors to place these carrier-agnostic lockers directly on public sidewalks.
Right.
The driver makes one stop, drops all 50 packages in the neighborhood locker, and just leaves.
And the Urban Freight Lab data argues the efficiency gains here are just staggering. Consolidating stops into a central neighborhood locker can reduce the time a delivery truck dwells at the curb by up to 33%.
Wow.
And it slashes overall delivery times by almost 80%.
That's incredible.
It cuts down the physical miles the vehicle have to travel. It entirely eliminates the carbon footprint of failed delivery attempts because people aren't home. And it provides secure storage to stop package theft.
See, here is where I look at all this data and have to push back a little bit. If a city replaces one massive Amazon step van with 5 heavy-duty cargo trikes and 10 autonomous sidewalk robots, aren't we just trading street congestion for absolute chaos on the sidewalks and bike lanes? I mean, how does a city prevent the physical space from being totally overrun by private delivery tech?
That is the big concern. And it raises an incredibly important question about governance. The Urban Freight Lab stresses that intense public-private collaboration is literally the only way this works. Cities cannot take a passive role here and just allow private tech companies to dump thousands of robots onto the pavement unchecked. They have to actively use their permitting power.
Like New York is doing with their microhub pilots.
Exactly the kind of regulation needed. Cities have to dictate exactly who can operate. They have to cap the number of vehicles or devices in a specific zip code, strictly define where they can travel, and require the private companies to share their routing data back with the city's Department of Transportation.
Ah, so they have visibility.
Right. The researchers argue that cities have to actively use zoning and curb management to force the private market into a footprint that is physically smaller, audibly quieter, and environmentally greener.
It is a massive mechanical and logistical puzzle. Okay, let's look at the full picture we've built today. We started with a consumer EV market that is definitely not failing, but maturing, shifting heavily to a used market where prices are stabilizing and everyday drivers are stepping in.
Yeah, and we connected that pause in the new market to the impending solid-state battery revolution. By removing the flammable liquid and heavy graphite, the industry is preparing to roll out vehicles that are dramatically safer, incredibly energy dense, and capable of traveling over 1,000 kilometers.
And then we saw how dropping those super batteries into commercial fleets exposes severe vulnerabilities in our aging electrical grid, prompting the industry to rely on mobile charging as a service power banks just to keep the vehicles moving while the grid catches up.
And finally, we explored how truly decarbonizing our cities requires going way beyond just the vehicle's powertrain. It requires the Urban Freight Lab's three-legged stool, electrifying the fleet, shifting the mode of delivery to cargo bikes and drones, and rewiring urban real estate with microhubs and consolidation lockers.
Which brings me back to that initial feeling of whiplash we talked about at the start of the show. When you step back and look at where all of this 2026 data is pointing, the mechanical leaps and the logistical shifts, I want to leave you with a kind of provocative thought. As solid state chemistry allows batteries to become smaller and infinitely more powerful, and as our cities become blanketed by intricate networks of delivery drones, autonomous sidewalk robots, and hyperlocal microhubs operating out of old storefronts, the very concept of going to the store might become completely obsolete. So, what does this all mean for us? Think about it. What happens to the physical landscape and the social fabric of our neighborhoods when literally every physical item we could ever need, groceries, medicine, clothing, hardware, just materializes at our doorstep silently, invisibly, and with zero tailpipe emissions? Will commercial storefronts as we know them just cease to exist, replaced entirely by blank walled logistics hubs? We might perfectly solve the emissions problem and fix the battery chemistry, but in the process, we are completely rewiring how humans interact with their own cities. Keep your eyes on your local curbs, watch how the physical space around you is changing, and keep asking questions. Thanks for joining us on this deep dive.